For those who are coming, there is a small change. The talk is going to be in English. I hope everyone understands. Who doesn't, just raise a hand. No, I hope that's not it. Cool. Great. Thanks. I'm doing great. Yeah, awesome. And we will start soon. Okay. Hi everyone. My name is Maksym Barvinskyi, and today we are going to talk about QA service mesh approach, whatever it is. Don't be afraid you're not familiar with the term, because I made it up. And it's not the first time I talk about it, and the funny thing is, every time the name gets changed. So maybe it will change after today. I'll be happy to hear feedback from you or receive any message in Messenger. All right, let's start. My name is Maksym Barvinskyi. I am Chief Test Automation Engineer in EPAM here in Kiev. And I have total experience in test automation more than 8 years. I worked on many different projects, mostly with Java and Python, with Web UI API testing. But one of the projects was something special. And I learned a lot from it, and there I learned that we can make some things better by thinking more like a developer. Okay, so before we even start, I'd like to share a very good quote I really like from one of our solution architects. I know it is a best practice, but is it the best practice for our project? I try to ask myself this very question every time I try to apply. I'm thinking about applying any new technology or like language, approach, process, or even an old technology, because you always have to think about the context. And it includes this talk as well. All right, so I'll tell you a little bit like a story. And for the story, we need some start point. The start point was we are developing a big monolith web application with a huge team, about almost 200 people in general working against the same code base. About 60 of them were QAs, and the majority of those were automations. And one day, our business analysts make us happy with the following requirement. Our application, S-util, stands for System Under Test, FYI. Our application, System Under Test, is going to create some file like XML, JSON, something like that, on the local file system. And then it's going to consume it or delete it, or even send it far, far away. So, and when me as a QA automation engineer, I see on those arrows, and I realize that I would need to have a possibility to create that file without the application, because it's not possible to always do it with the application and test all the further scenarios, right? So from the test automation framework perspective, TAF's test automation framework, how do we test that? Anyone? How? SSH. Great. Yeah, that is a good one. But this is SSH solution demands some amount of work, and we didn't want to do that. So our solution was to come to developers with face like that and ask them, could you please just add some endpoints that we could create our file there where you deployed? And I believe you can imagine the developer face. That was something like this. And they said, come on, guys, we can do that. We're releasing in 2 years, and it's really possible that it will be a whole other team, and they will totally forget to delete it before release. And also, it impacts how do we manage, how do we control what we delete, what we not delete before release. So we had to think of something else, and that was SSH, exactly. So we created an SSH helper that did what we needed. It created files, deleted files. But if you ever worked with SSH through Java, you probably noticed it is a little bit like little hell. It's totally flaky, and it's basically it's working with console commands output. So basically, you don't even know what surprise is going to give you every next run. And before we stabilize that thing, make it stable, it got a little like a month. And then something unexpected happened. Like, the product owner said, could you please just run all your tests on our corporate network? We deployed our application you built, and you just run all your tests against it. But you know what? We don't allow SSH port open. It's our security policy, sorry. And we could start. Well, we had two options. First option, naturally, we could just skip those tests and don't tell anyone. The second option was to start a war against enterprise. And we could start a war if we would really happy with our solution. But as I mentioned, we really were not. So we had to think of something else. And I thought, well, we have port 80 open. So basically, we can just deploy another web service that would work with our file for us on the server side. And we could call APIs, like create me this file or read me that file, and that would really look like more robust and right solution. And it really was. Basically, the benefits of this solution is quite clear. We don't depend on any security policies, open ports. The solution is much more robust because we basically work with the local file system with Java. And it's much faster to implement, again, because of that. And there are no really ugly code in our test automation framework, like thread sleep or something, because, again, there are no working with console commands. What are the drawbacks of this solution? Well, the time that we saved, that we would save the time that we would save, we would spend on different things to make it right. That would be creating some kind of a CI pipeline for that web service, Fs-util, right? And we would need to spend some time for deploying or including it in some centralized process, but still, there are the drawbacks. And our business analyst would like to make us more happier, and they say, okay, the next thing, we need to integrate with message queues. I believe everyone knows approximately what is it. Raise a hand. Who knows what message queues are? Yeah, those are basically just a simple thing. They're string messages and first in, first out, nothing special. So our application would need to send some messages to inbound queue, outbound queue, and read them from another inbound queue. How do we test that? Well, the first thing that comes to mind to find a Java library and work with the queues right from the test automation framework. It really went well. It didn't take long. So I created this binding, created this solution, pushed 3-4 tests before I go home, and on the morning after, I see that one of those tests failed because it didn't get the message, but it worked yesterday, and I checked it manually. It worked. What happened? Why one of the tests didn't get the message? The parallel run happened, and in particular, this part. When you introduce a new consumer for the queue, the funny thing that queues don't stay messages don't stay in the queue. So if you introduce multiple consumers, only God knows what exact consumer will get this message. So this solution didn't work with parallel test run, and we had some situation called race condition. How do we overcome this? How do we fix this issue? Well, we came up with another web service. We called it Mq-util, and we said everyone, like I caught everyone in the office and said, hey, we work with message queues through Mq-util only. Don't you dare to get messages or send messages directly. And that worked. Basically, there was some kind of a cache in Mq-utils, cache of messages, and it saved them for us. And whenever we would like to get the message or send the message, basically all those kind of operations, we would work with Mq-util through REST API. As you can see here, it is not necessarily should be deployed there on the server, but it was the easiest way from my perspective to guarantee the relation between system under test and Mq-util one-to-one, because it's obviously you have to have always one and only one instance of Mq-util for every instance of system under test. So that was it. Benefits are quite obvious. We can run our tests in parallel now. And also, it made life easier for manual testing. We don't need any additional software for manual testing message queues, and also there are no race condition for them as well, because as you understand, it also would be a problem. And the drawbacks are the same here, because basically it's another artifact in our infrastructure. So we would need to create some kind of a good pipeline and again, deploy it. Our business analysts are non-stop. They say, okay, another thing, guys. We would like to integrate with another third-party system. Some kind of like a really third party, like, I don't know, weather forecast. And naturally, we would need to mock it because we cannot work with production instance. And we also added there cool functions like we would not also answer with some static text, some static values. For example, we don't always say 25 degrees in Los Angeles, but we can also set these degrees by another API. So we kind of created this kind of mock. But we are lazy, and we deployed it only on one server, server Z here, and worked with it from multiple instances at the same time. But what happens when we need to test different versions, right? Well, and at the same time, we cannot afford that. But basically, here, the solution is quite obvious. Start to work more and make it right. And basically deploy every instance of this mock to every instance of the server. Sounds good? Then, when you look to your infrastructure, like your CI, your documentation, and you would like to be it clear, well organized, easy to orient there, and our infrastructure was some more like this, because those artifacts were created by different people. No matter I told that we need to create CI pipeline, but they did create CI pipeline, and it was like a mess because different people develop in different styles, and they don't follow the process. Basically, it was not any process. So I looked at one of the environments we had, and I thought, how can we make a little bit easier for them to follow for every new contributor, every new artifact there? Couldn't be like easier way here? And I thought maybe we could combine it. Wouldn't it be easier? And call this artifact QA Web Services or QA Web Service. So that would be deployed on the same container, just with like /QAWS, and we can call all the endpoints from here, like QAWS, create file, QAWS, send message, etc. And that really did well because it was much easier to document it. It was much easier to deploy it, to include it into general deployment procedure. And also, it was much easier to explain our customer what the hell are we deploying there on their environments beside the actual application. And when we did that, it turned out we could do more. For example, we could basically get any kind of environment or application properties dynamically. It helped us. On our project, we used it to retrieve database URL dynamically because from time to time, it get changed. In our case, it was once 2 weeks, something like that. And we were lazy. We didn't want to check. It wasn't even the lazy factor, but were not any any kind of notification, centralized notification about that. So our DevOps just did it without any prior notification or something like that. So that was really safer for us. Also, what can you do? You can put, for example, you run your tests parallel your tests using different Jenkins jobs, not the Java threads like Selenium Grid or Selenoid. But for some reason, you do it like that. So you parallel your tests with different test suites that don't know about each other. And in QA web service, you can put any kind of thing that that would hold some common context for those test suites. For example, it could be the test queue, basically, and your executors could work with it like that. Just ask for another test to run it, and then ask for more until the queue is empty. It is basically the most efficient way of test parallelization. Also, you can put there some kind of let's say you have in your application you have users which cannot log in from the different browsers at the same time, and you have 1,000 UI tests and would like to run them in parallel 10 threads. So in general, you would need to have 1,000 of unique users for every test, so so you can guarantee they won't fail randomly. But in this case, you can put here some pool of users in QA web service and just tell your test to ask for every new user for the test and then put it back when it's done. Something like this. So we came up with an approach. I called it QA service mesh, but the mesh part I will explain later. So it is an approach in test automation architecture to have a single web service or even web application with UI, why not, that serves different testing purposes. Its relation to system under test is always one-to-one. You have to guarantee it. And deploy it at the same container, same server where the system under test is deployed. And also, you have to make sure that system under test doesn't know anything about QA web service. And what are the benefits here? You have less artifacts. Basically, I didn't find... the benefits. So you have less artifacts and simpler infrastructure. You got easier deployment to production because you just don't deploy your QA web service there and everything works. You didn't modify any of your application. And also, when we're talking about adding something, these are the benefits of combining, right? Of combining solution. When we talk about adding some things, it saves a lot of time because we already created a web service. So to add some, for example, reading the environment variable API, we just need a couple hours, including code review, instead of a couple of days of creating a new project and including it, document it, explaining customer, etc. And what are the drawbacks? Obviously, you need to have a higher level of technical skills of at least one from someone from QA team. Maybe you could work with developers here, but they could, for example, explain you exactly what they do, so you can make sure that they don't use anything from the system under test. And in some cases, it is more complicated infrastructure. It is, in general, using web services for testing purposes there on the server, because automation engineers not always very good with that. They came to me and say, why we work with message queues with using some application, not the right there from the tests. And I had to explain them, but it wasn't a big deal because I had a good explanation. What about microservices here? Because all the time before I was talking about monolith. So what about microservices? Basically, it is the same. Just replace on every slide before system under test with web service, with microservice, right? And you would get something like this. It could be useful for you. Basically, you have still those cases with file system operation and message queues. You can also check logs of your every service you have in the system, and for example, you run your UI tests, and every time it fails, it also collects the error messages from the logs from every web service, something like that. So basically, quite a useful thing for QA automation, even for manual QA as well. And let's imagine someone of you found it useful and would like to apply this approach on their project. So I have some useful tips for you then. First of all, don't forget to really create CI pipeline for that. Because basically you have to treat it as a separate software product. Also, deploy it on every environment where you're going to run your tests. Don't think that, okay, I'm not going to run a test that use QA web service on that environment. I won't deploy it there. Just include it in some general deployment infrastructure using Ansible, and you'll be done. Won't be worried about stuff like that. Don't forget to write documentation. It will help newcomers to know what it is. Introduce it as early as possible on the project. Basically, because moving to something is more expensive than make it that way from the start. For example, if you feel like you need to create at least one of those artifacts I talked before, just name it QA web service from the start. Even when you don't see the further APIs you're gonna add, it may come later. So just make it general from the start. Tell everybody on the project about its existence and its purpose. Every junior developer should know what is that, and of course some architects and project management also, because you don't know where your next contributor will come from. Yeah, different needs on the project, especially in big projects. If you don't communicate like closely, if you're more than 5-10 people. Assign an owner, yeah, because you know that responsibility divided by 2 equals to 0. So there must be some person that will be responsible for the place of that artifact in your infrastructure. It doesn't have to be the main contributor, just the person who would work with DevOps, who would be the mandatory code reviewer, something like that. And also don't put there something it doesn't fit. For example, assertions. You might think it could be a good idea, but it's not. Instead of getting a message and parse it in the test, you think, hey, I could just check it right there on QA web service. Don't do it, because basically tomorrow you're gonna need another assertion. So if you even do stuff like that help you, you have at least have another endpoint that would get you a raw message that you could work with in any way you like. All right, and also I have an example. You can check it out on my GitHub. It's called QAWS example. You won't miss. It is written in Java using Spring Boot. In the description, I believe you would find what it does, and maybe it will give more vision to you that what the hell I was talking about all this time. Okay, and that's about it. Thank you. You can find me. Drop me a message there, and maybe you have any questions.
Thank you. Why mesh?
Oh, right. I forgot. Totally forgot. Yeah, it is because there is a service mesh term. It is a service mesh, and it actually a totally different thing, but with QA service mesh has one common thing. There is a satellite of each microservice from our side. In service mesh, you have something like load balancing, logging, monitoring, service helper for every microservice. And in QA service mesh, you also have one-to-one. You have one satellite for every microservice. Just it serves QA purposes. So this is one mesh. Thank you for your question.
Thank you for your speech. Please talk me about some things that how to explain the client that is necessary for our projects, because I have a lot of situations where the client doesn't want to pay money on the QA stage even, and so on. It's the first question, and second one is related to microservices architecture. How to support QAWS services if my microservice architecture every time changes, and you should support these QAWS services. Who should do it?
I see. Thank you. First question is about explaining customer. Well, every customer likes money. Time is money. So basically, when you explain something like when you compare hours to days, they generally believe in that. So if you tell that now we're going to spend some hours instead of days, but I need a week, for example, to implement this new solution, they will probably be good with that. In general, we solved our problems I talked about. So if you think about it, in our case, it was basically the only solution. So except like not running some tests, of course. But the demand was to to run all the tests, to automate as much as possible. So we did that. Yeah, and the second question is about microservice infrastructure. Unfortunately, didn't have much experience with having that in microservice infrastructure. So I cannot tell you that for sure, but in general, I believe that if you don't have like a vital necessity in that, like you lived with that, without it before, and it's okay, and as you said, microservice infrastructure always changing, then probably you don't need that on your project. Because remember, it's always depend on the context. You see? So you have to always think about pros and cons.
Thank you for the presentation. I have a couple of questions. So the first one is code base wise. Is it the same application that is just deployed alongside each of the microservices?
The code base is different, totally different. It's a totally different project.
But it's one project. It's not like multitude of QA web service applications.
Yeah, exactly. It's one, well, yeah, it is a Spring Boot application with different API right there.
Okay, and technically, how's it like working together? Like, for example, I have a microservice running in a Docker container. So this test QA utility would need to run the same container?
It should be run in there in that same container. For us, it worked because we deployed it. We run Tomcat in container, and we deployed our QA web service in the same Tomcat that allowed us to make it deployed with the same URL, just with a different QAWS. It won't work with standalone. It will, like, it's not going to work, but it will have less abilities, less capabilities running in a different container, like a Tomcat. You see, web container, I mean. But you can still, I believe, run it in Docker as well, in the same Docker, even if it's standalone web application. I believe you can do that.
Okay. Could there be potentially a problem that they share same resources and maybe that
yes, exactly.
some issues?
Yeah, you have to pay attention to that. So I guess if you would really try to do something like that, you will have to include always your developers in code review, at least. Well, basically, this is it. In general, the things I told about, they don't even like working with local file system or with message queues. They don't interact with the application. So, well, yeah, you have to watch out and make it independent, so that in production you can just skip deploying QA web service, deploy just your system under test, and everything should work.
Okay, thank you.
Mm-hmm.
Thank you for the presentation. The question is, QA web service is the software, so it contains bugs potentially.
Sure.
How far did you go to the quality assurance of this service, and have you faced any false positive or false negative test cases due to bugs in QA web service?
It potentially can contain bugs. Thank you for your question. I went to unit tests. This was the farthest I went. But in general, it is quite we found it quite sufficient just to check it manually for the first time. It works, and then just use unit tests just to make sure everything's good.
If you convince your customer that you need to write a unit test on QA web service, you should probably do all the pre-sales in the company. Thank you.
It was the thing here is that it really it is really a small web service. This is the key. It's not like something big, so it is quite easier to maintain. Actually, it's like create file endpoint or read file endpoint. It's quite easy things.
Any questions?